We begin with a miss. A child winds up, releases, and the ball goes wide. The target remains untouched. Through repeated attempts, a human learner evaluates the distance from the target, adjusting the grip and release. Artificial intelligence navigates a digital version of this same refinement process. The central problem of machine learning is the return journey. We must ask how an error at the end of a long sequence sends a corrective signal back through the hidden connections that shaped the answer. AI Mathematics Ladder, Book 8, approaches this question from first principles. It treats complex networks not as abstract math, but as a series of observations rooted in the mechanics of everyday life. True learning, whether in a human mind or a digital network, requires a shift in perspective. A failure is not a verdict. It is a map that allows the learner to trace a path back to the source of the error. Every output is the result of linked change. A process moves forward, where one action influences the next, much like a river branching into streams. Between the initial input and the final result lies the hidden middle. These are intermediate rooms or stages where information is transformed before we see the final outcome. Consider a complex stew. The final flavor is the product of heat, timing, and mixing, invisible middle steps that completely disguise the raw ingredients. If the final result is flawed, staring at the output provides no diagnostic data. Improving the system requires accessing those hidden stages to trace how the message changed along the route. We analyze these stages through local sensitivity. We ask what happens to a specific system when we nudge one input slightly. As the crank rotates, the connected window panel shifts open by just a fraction. That small physical reaction triggers a cascade. The open window allows airflow to change, which then causes the room's temperature to drop. The intelligence of the system is built upon this precise chain of reactions, where tiny, linked sensitivities respond to one another in sequence. In a network with thousands of intermediate steps, calculating the cumulative effect of all these independent sensitivities becomes a logistical challenge. We use this model of interlocking gears to visualize the mathematical bridge for this problem, the chain rule. The chain rule evaluates each component individually. As gear X drives gear Y and gear Y drives gear Z, we measure the specific rate of change at each point of contact. Multiplying these local sensitivities together connects the final output all the way back to the initial starting condition. The chain rule provides a language for compound influence. It lets us read a multi-layered network as a single traceable story of cause and effect. The backward journey begins by measuring the error. We use a scale to visualize the mismatch between a target and actual weight, a gap known as loss. This is an objective distance from the goal that must be measured before it can be closed. Correction requires direction. We look for positive and negative links to determine which way a specific dial must turn to reduce the error. In this context, a negative sign is a mathematical compass. It points downhill toward a smaller error and a more accurate model. If a system attempts to adjust all its hidden variables at once without tracing the specific cause of an error, it fails to learn. Backpropagation replaces that panic with a trace. The final error acts as a lantern, sending a pulse of guidance in reverse down the established path. Using the chain rule, backpropagation pauses at every hidden step to ask exactly how much of the final mistake belongs to that specific node. This disciplined system of accountability ensures that each adjustable part of the network receives the information it needs to improve. Tracing the error backward turns a useless mistake into a structural blueprint for the next adjustment. Measured, observational. We return to the learner from the opening scene. This time, the release is adjusted, and the ball falls perfectly into the glove. This result is not a solitary event. It carries the compounded history of every hidden choice and every measured failure that preceded it. When we trace our mistakes backward with accountability, we provide the beginning of the journey with the specific information it needs to succeed.